Hello everybody, welcome back to a new video. Today we're going to continue with our bike, specifically the pedal this time around. Quite a complex construction really. It's going to be a lot of Boolean modifiers used, but I mean nothing so intense really. It's quite a lot of work, but very simple work. So here we just simply begin with the major shape, which is a sheared rectangle. It's always best to begin with the major shapes. And this pedal, I'm not sure if it's the actual stock pedal of this type of bike. I had a look around, but I found this one and it looked quite nice. It does have the GT logo on it, which makes me think maybe it is the stock pedal. But mainly I found it and it looked very fun and interesting, and I think it will look really good on the bike. So we go for it. We go for this one. So here you can see the left and the right side is not exactly identical, which will bring some problems. We're going to be very restricted with the use of the mirror and the symmetry modifier. We do use it a little bit and it will cause problems, and there will be a bit of cleanup, but it's not too bad. These images I've just found online. Anything will do, just some kind of top view, side view, something where you can get an idea of the actual form. Here, strangely enough, I don't seem to be able to scale in. Never really found out why here, but it's fine. And here it's just easier to use the knife tool to cut ourselves some new edges here. So the fill function you've just seen, I'm not sure which modifier. If there's a modifier where you can use that function, it may be F2. Maybe the F2 or the mesh tools. Either way, it's a modifier which is included in the Blender build, so you just need to activate it. So here we use our first boolean just to cut out the internal piece here. We stole some of the geometry from the actual pedal and reused that as a boolean. And here we're going to create this central shape here. Which is a hexagon, is it? 6-sided hexagon, maybe? Or maybe it's 8-sided. It looks like it's 8-sided. Octagon. Always try and make use of the snapping tool. I think it's a very good tool to use. I've leaned on it quite heavily in these videos. There was a time when I started with Blender, and just like everybody else, you didn't really know the tools so much, so you spent hours just trying to eyeball things, trying to get things at the exact right height. And I guess it was a failure on my part, because I'm one of the very, very few users who sat down and, among other things, watched the donut tutorial. So I think I've maybe missed quite a lot of the default tools in Blender. Maybe I should sit down and just go through them. Watch some kind of tutorial of all the absolute basic Blender tools which I miss. I don't even use any of the T-bar. You notice on the left side you have the T-bar. I never use that. I don't really know what half of the icons actually mean. So here we've boolean together this middle octagon and the outside, and it does leave quite a lot of nasty geometry left over, so we just need to clean it up. And quite a large part of this video is cleaning up geometry, actually. As normal, we're on twice the speed here. I think if we had this in 1-to-1 speed, it would be quite boring to watch. In some other videos where things are a little bit more complex, I've even sped up this part of the video, but as it's the main part of this video, I've left it on the general double speed. But here we're just trying to collapse geometry, clean it up, keep it simple. Try not to compromise our shapes. See here, you could already see there's an internal face. Just adding some edge loops here to get the connections. Make sure we get some good flow. Here you can see the internal faces left over from the boolean. I'm not sure, maybe you have more faces left over when you use, when you add the boolean, you have exact. Sometimes you're forced to use the exact function, and I'm not sure if you get a lot more faces left over, a lot more work to do. See here, we cannot use a symmetrize left and right, but what we do, we copy just the middle piece and try to symmetrize on the y-axis. It's actually easier if we just delete one side here. If we can get the right. So we need a connection here so we don't destroy too much. Just trying to localize what we're deleting here. So we delete here, and then this central piece we should be able to and then this part here. Okay, so that central piece is fixed. So now we're going to see if we can find a shape for this cutout in the side of the pedal. We need to know how far to the left and to the right, because it's going to cut into the side here, and we need to know how much into the side it's going to cut. And we just move these sides out a little bit just to make way for it. So here we define the actual shape of the boolean. Just a simple rectangle with some beveled edges. So now we're just checking how much has been taken out the side here. So our references show it does cut into the side a little bit. And now we're going to define the same cutouts for the sides. We have 3 of them here. You see, when making complex objects like this, I think the Boolean workflow is the best way. I mean, if you imagine trying to build this pedal with just building blocks and extruding, it would be an incredible amount of work, to be fair. It is easier just to use the Boolean workflow and go in and spend your time cleaning things up. I mean, most of these objects are generally made in the same way. You start with a big shape and you just take pieces away to make an interesting design. So here we're just adjusting the scaling to make sure it's not too wide. And you can see here the Boolean's acting up, and it's because it's right on. You can see that our little we have an edge loop which it's trying to fight with. So we just move it and shrink it a little bit. You can see as soon as we move away from that edge loop, we see the Boolean. Right now we have it intersecting the middle piece, which we do not need. It does need to go through the central piece here, just the edges. And when we're happy, we commit to the Boolean. And then there is at least one more small circular cutout on the side here. I always think it's interesting because when making this object, you do your research, you look at references, and you spend quite a lot of time trying to work out how does this look, how was it made. and it takes a lot of work trying to find decent references, but as I've said many times before, if you need to look at how it is made and try and find really good references, then when we're done with the complete bike, you're not going to be looking at these small details. We just need to try to make it look as realistic as possible. Obviously, if it's way off, then it's going to look terrible. But I'm happy with the amount of work we put into this. I've seen obviously the final pedal with the texture, and it does look good. I think it definitely would pass as a real actual pedal. Even as a close-up, and obviously we're not probably going to be having so many close-ups of these pedals. We'll be viewing the bike maybe from a little bit of a distance. If anybody was going to use or animate this bike, you're not really going to have super close-ups. But because we're taking so much time and adding so much detail to this bike, it will look great in whichever way you choose to use it. And I mean, if it's a portfolio piece, you want it to be good. The improvement I think we could, when I say we, I mean me, could make with this bike is probably the texturing. I wouldn't say I've taken a huge amount of time texturing this bike. I put some effort in. Marmoset isn't my strong suit right now. I am getting better, and I think I could have maybe gone a bit better, but I don't know. Maybe I'll do one more pass when we're done with this, because we still need to render the bike, and I'm not completely sure if I want to stick with this sky blue bike, so maybe I do go in and redo the textures for the final piece. Here again you can see a lot of leftover geometry from a boolean. So here we're like 20 minutes in, and you can see we've got pretty much the main shapes we need for this pedal. Now it's a decent amount of cleanup, which is just collapsing vertices. We add some triangles here because there's a huge amount of flat surfaces here, no deformation, so we can cheat a little bit on the geometry. It's fairly unnecessary to make completely perfect geometry here because it's going to add to our render times. And if anybody wants to use the bike, obviously you don't want to have huge files also. It already is going to be a huge file because we have UV maps for pretty much every piece. And that is another thing which we could do with this bike. I'm not going to do it here in the video, but to make it more interesting for the viewers, I have tried to render each piece at the end of a video. But the best way to make this bike would be to use the UDIMs, where we have multiple maps. So this bike would be about 10 different UDIM tiles. So it would be self-contained. But the problem being, if you would call it a problem, is that if you wanted to change this bike, maybe change out the tire, the tires, the rims, maybe different pedals, then you would have to redo the UDIM tiles also, which I felt like I wanted to make this bike more modular, where you should be able to just change pieces out. Because bikes are essentially modular, right? I mean, you can buy a new saddle, you can buy a new pedal. So here we're just trying to find some solutions to these vertices. I'm trying to avoid any kind of super extreme angles here. So I wouldn't blame you if you skipped ahead from these parts. Like I said, if you think it's fun to fix the mesh here, then feel free to continue to watch, but you can hop ahead. We do get to a point where we are fixing the booleans and all the bevels and the final pieces. But there's still a little bit more geometry to make also. But I kind of felt it would be cheating a little bit just to skip so fast through all of this. I mean, hopefully there's some people sat here watching not really knowing how to solve these kind of problems. And I mean, it's free content, just skip it if you want to skip it. We're literally inside the pedal here, so even if we had any kind of shading errors, nothing is going to be so visible here. And this is the downside, I guess, to the Boolean workflow, fixing the mesh afterwards. So here we're going to see if we can use, because we fixed one side, we're going to see if we can use the symmetrize modifier, but you can see it is off. So if we are to use it, we're gonna have to compromise and try and fix afterwards. Quite literally meet in the middle. So here what we do, we take the whole left side, once we fix any small errors we're going to see. And then the idea is that we're going to flip it to the right side and then rotate it 180 degrees up and upside down. So just checking to make sure we've not missed anything here. What we probably have is a lot of geometry. Here we just try and neaten things up a little bit. Let's run the flatten function on here. Okay, so we take this side and we copy, symmetrize left to right. So now you can see it's identical and we don't want that. We need one side to essentially flip. So we rotate it and then move down. So we're just going to separate this side piece here so we don't get so much problems with the middle, and then we rotate it. So then we don't have to play around with the middle piece. And now we just need to try and resolve the mismatch here. So if we would have taken it from the middle like we originally tried to, there would have been more work to do. But you can see with this process how much the mirror and the symmetrize saves us. It wasn't too bad, we're already there. So now all the work we did on the one side is now copied over to the other. Here's a function good to use where you check for pieces which are non-manifold. So here we find a lot of internal vertices which we missed the first time. If you have problems with your bevels or shading errors, it's always worth checking for pieces which are non-manifold, and Blender will highlight for you the issues. You'll see we're going to go back in, we'll resolve these small issues here, and we'll run the non-manifold again. And it's quite likely you find these errors, especially when you've been relying so heavily on the Boolean. Okay, so then we can try the non-manifold. So there you can see two more pieces. And again, it's an internal piece mesh here, left over from the boolean. Quite a simple fix just to collapse those pieces. Same on the other side. Test again, and there you can see we've missed collapse in here. Same on the other side. Test one more time. Non-monofold, no highlights, so our mesh is working as it should do. So here we have the bolt, the part which actually connects to the crank. I'm not sure if we have a good visual of it. Maybe we do from above. So essentially a bolt. Maybe it's not even a bolt. I mean, it's a bit rounded, but it has two flat edges, which we need to make. And also here there is a rubber logo which we're going to extrude. Duplicate the mesh and extrude. So we don't make the actual bolt here, we're just making the hole for the bolt. Preparation. And you can actually see from this view here the little bolt which we're going to make. So here we're using the active element to flatten it. The active element essentially, the last vertice you click, which is shown in white, that will be your active object. So you're essentially using that vertices as a as the point of which you want to rotate things or collapse things or flatten. Is your anchor essentially. You can use your 3D cursor. I use that one quite a lot. Rotate things around your 3D cursor or collapse things onto the 3D cursor. But active element is also a very good one to use. Essentially you don't need to move your 3D cursor around, and many times you maybe if you want all the edges to be flattened to a certain point, then use your active element. If that's unclear, which I expect is, consider my explanation. Maybe go find a tutorial on pivot points. Hugely important. So here I see just above this bolt here we have some dark shading, and I guess it's some overlapping geometry. Here we can separate the bolt completely. It does not need to be a part of the pedal. And then we can collapse this a little bit. It's never a terrible idea to try and add some visual detail. We can see in our reference that there is some beveling to these small parts which stick out, but visual interest is always good. As a part of this process, I actually did make the crank, which is the bar which goes from the bike to the pedal, but I felt that the video ran a little bit too long. We're up on maybe 1 hour 20 minutes, which I didn't want it to be that long, so that part is recorded, but I'll add it to another video. We have brake levers and brake pads to do. Also grips to our handlebars. And then our final render, which I'm not too sure. I'm not too sure if I'm going to do a render video just with this bike. We'll see. If I do a render video, I maybe want to do something a little bit more simpler. This rendering, getting a good render on a bike, it's quite a big process, I guess. But we'll see. Maybe we can do one render. Here we're just trying to find solutions to the geometry so it doesn't seem like it looks a bit soft on the inside there. Again, we're probably never gonna see that, but anyway. Here you can see we have the overlap. Here we just flatten the selection. Also absolutely great tool, the flatten. So now we add our bevel, and there will be some editing involved here. The shading you see now is because we have some tight geometry in certain places, so the bevels are essentially overlapping each other, which creates this crazy black geometry. The solution is almost always just trying to edit the geometry. Here we add a subdivision surface just to see how it looks with a subdivision. It's not necessarily that we need it really. It kind of works with our smooth So here we're just scaling to try and find what the solution is to the bevel here. You see the faceting here is because of the angle of our smooth, auto smooth. Or the angle of our bevel it was actually. Which we choose not to go with the angle of the bevel. We're going to go in and just define our edges on our own instead. It gives us a little bit more control, I find. So here I've speeded up to ×4. For some crazy reason I actually go in and define all the edges by hand, where what I should have done is go in and choose select sharp edges first, which pretty much does half the work for us. But I don't know, maybe I was tired and didn't really think about it. So here we're just marking the bevel edges and change our bevel to weight instead. So here's an angle on the inside which we seem to have missed somehow. So we're just going to fix that quickly. And the same here. Was clearly not paying attention. But it's fine, it's a quick fix. And then redefine the edges for the bevel. There's always something we miss. Such is life. Down here also. Such amateur behavior. But I have sped up the process for you anyway, just so you don't have to see it again. And then we tried to fix the geometry a little bit, so a few pieces I'm not so happy with. It's quite crazy that I did not use the sharp. But you know, you get what you pay for, people. It's a free tutorial. That's where you get to see my amateur behavior. If this does interest you, obviously just slow down the video. But it's just much of the same here, defining the edges, fixing the errors. And here we are approaching normality. So what we need here is a edge loop around these rings here, and the solution is to extrude inwards and then we can scale up the entire circle. So we have way too tight geometry here. And it's a constant fight because we want to have a bigger bevel to give us softer edges. But whenever we have bigger bevels, then there's increased chance that they overlap with their neighbors. So every time we increase the bevel size, we need to then just make sure that there's no clash. And here also, a little bit too tight geometry. Just trying to scale things here and fill out a little bit. I test to do an inset here, but I don't think we actually need it. And again, more spacing after we increase the sizing. And here we can scale it down a little bit. There you go. So, progress, pedal screw, I mean, it's not the most exciting thing to model, I guess, but if we're going to make the bike, we need to make the whole bike, so what are we going to do? I don't just want to skip parts. I want it to be a complete model. Here again, we're still just trying to find out why we're getting bevel overlaps. There you go. So here we choose to actually take away the bevel. We join it with the screw instead, so we're actually using the subdivision modifier just on that piece instead, which works fine. So now, as you can see, we have these small studs, which we are going to add. And the easiest solution here is a method we've used before, where we will shrink wrap the bottom vertices to the surface of our mesh. It will be a huge pain in the backside to join them in the mesh, and even I'm not that crazy. So we add this bottom set of vertices and add them as a vertices group. Here I actually add the bottom as 100% and the next row as 50%, but I think actually take it away is not very necessary. Here we actually have a bottom face we need to remove, which we do not need. See, the shrink wrap is causing a little bit of a pain here. We don't need that much. And then we duplicate and just eyeball it. I'm actually proud of myself how I literally just eyeballed this, as opposed to normally I would just go crazy for the positioning. And then we take all of them and we duplicate, flip on the z-axis, or we symmetrize on the z-axis. So then we have our studs. With the shrink wrap modifier, looks absolutely fine. So now we're approaching the end of the video, and I add the material here so you can see the final pedal with the material, which looks pretty good. I add a nice amount of dirt to this one, which feels like it should. I mean, it's a pedal. It's going to be a lot of shoes on the thing. So here we go. Add the material to this piece also. So, not too bad. It's meant to be kind of like a hard rubber, and it does the job. I think that's going to fit in really nicely with our bike. Worth the amount of effort we put in for it, I think. This looks nice. I'm proud of that. So, yep, thanks for this week. We shall continue. Maybe a different video next week. We'll break it up a little bit. We'll see. But thank you, and we'll see you next time.